Hello students, hello everyone. Welcome to Senior College Mathematics. Topic of discussion is surds or radical. If you are in senior college, preparing for WAEC, for NECO, for GCE, for NAPTEP, for JAMB, or any other external exams into high school, this topic, this lesson is for you. Lesson 2, operations with surds. And the first set of operations that we'll look at is addition and subtraction of surds. Addition and subtraction of surds. Before that, for updates, follow PetakusEduCom via YouTube at Petakus Simplified Maths. To do that, subscribe to this channel, like and share this video to your friends, to your colleagues, to your classmates. Facebook at fb.me/PetakusEduCom, Instagram at PetakusEC, Telegram t.me/PetakusEduCom, WhatsApp through this mobile telephone number. In all of these platforms, you get updated from time to time about what is happening at Petakus Education Community, where you have access to quality, unlimited, and simplified mathematics teachings in series. Yes, bit by bit learning. Addition and subtraction. Let's go. Only similar or like sorts can be added or subtracted. In lesson 1, where we stated the basic rules, I said that when we have that root A plus root B cannot be added, but root A and root B. So root A and root A, they are like or similar. So you can only add root A and root A. Two sorts are said to be similar if their irrational parts contain the same numeral. Irrational parts, the part that you cannot determine its square root if you have the same number. As me, for example, look at 3 root 2 and 7 root 2. In these two examples, their irrational part is 2 and 2 and have the same number. So root 3 root 2, 3 root 2 and 7 root 2 are similar or alike because their irrational parts contain the same numeral 2 and 2, so they can be added or subtracted. On the other hand, look at 2 root 3 and 3 root 7. These two sorts are not similar because their irrational part contains different numeral 3 and 7, and as such they can neither be added nor subtracted. You cannot add different sorts. You cannot subtract different sorts. Are you following? Okay. Sometimes, in order to have similar sorts, one may need to simplify such sort before attempting adding or subtracting, because sometimes if you see the problem initially, it may look as if they are different, but you have to simplify them first for you to conclude if they are similar or not. Okay, ensure that you always simplify. Don't just conclude at the initial stage that this problem cannot be solved. No, you only conclude after simplifying to the best, simplest form before you conclude. Okay. So let's take some examples. Let's take some examples. Evaluate the following. Example 7. 2 root 135 minus root 375 plus root 60. Now this is the reason why we started from basic and single form of surd, so that when we encounter problems like this, we know how to simplify them using the idea of basic and single forms of surd. Okay, so in 135 you look for the perfect square inside, and I told us how to do it. You keep on dividing by non-perfect number such as 2, 3, 5. When you do that, by the time you get to 15, you are going to have 9 times 15, because 9 is a perfect square. For 375, when you also get to 15, you have 25 times 15. Then when you look for 60, you have 4 times 15. Now listen, as you are doing that, you bear in mind that what you are looking for is a similar surd, because in 60 you can actually have 5 times 12. 5 times 12. But now if you look inside 12 again, 4 is there as a perfect square. So to avoid such procedure, just look for the perfect square directly. That factor that is a perfect square, look for it directly. So in the three numbers, we have 9, 25 and 4 and 4. Okay, so if you check square root of 9, you have 3. Of course 15 is a non-perfect square, it will also be under the square root. Square root of 25 is 5. Square root of 4 is 2. So you see that all the surds are similar because they have the same numeral. Their irrational part 15, 15, 15 is the same. That means you can add and subtract. See that? Okay, let's multiply 2 by 3 first. That is 6. Okay, now this number and these ones are positive, so let's bring them together. After adding, then we subtract. So what you are adding here now is the coefficient. Like when we have root a plus root a, we said is 2 root a. What you are adding is 1 root a, 1 root a, the coefficient 1 and 1. So if you add here 6 plus, that is 6 root 15 plus 2 root 15, you have 8 root 15. 8 root 15 minus 5 root 15, you have 3 root 15. You have simplified that problem. Example, okay, example 8 first before 9. Let me quickly adjust that. So alright, so let's take example 8. You have root 48 plus root 12 minus root 75. If you look at all the perfect squares in 48, 12 and 75, this becomes root 16 times 3, root 4 times 3, root 25 times 3. Root 16 is 4. You are left with root 3. Root 2, root 4 is 2 times root 3. 25, the square root is 5 times root 3. If you add 4 root 3 plus plus 2 root 3, you have 6 root 3, minus 5 root 3, you have 1 root 3, also written as root 3. The coefficient of 1 here is always invisible. It's only attached as from 2, 3, and so on. Example 9. 2 root 125 plus root 45 minus 8 root 5. Okay? If you look at the last term, 8 root 5, root 5 cannot be broken down than the way it is. So it means that if we are looking for similar surd, we must do that in respect to 5. Okay? 125 can be expressed as 25 times 5. 45 is 9 times 5. 25, its square root is 5. You are left with root 5. For 9, its square root is 3 times root 5. The third term is already in simplest possible form. If you multiply the first one, 2 times 5 now. So you have 10 root 5 plus 3 root 5 minus 8 root 5. If you add first, 10 root 5 plus 3 root 5, that is 13 root 5 minus 8 root 5, that is 13 minus 8 now. So you have 5 root 5 as the answer for simplifying that surdic expression. Example 10. Simplify root 3 plus 1 over root 3 minus 1 over 27. This is like solving fraction. But before then, look at the denominators. Root 3 root 27. You can write 27 as square root of 9 times 3. Square root of 9 is 3. Then you have 3 root 3. That is what you have here. Now, there's what I call balanced fraction. In balanced fraction, all the terms have numerators and denominator. For that, you write this one as over 1, as you have here, to have a balanced fraction. Then you find the LCM. The LCM of 1 root 3, 3 root 3 is 3 root 3. You write down the LCM and you apply the rule of dividing the LCM by each denominator and your answer times numerator. So if you divide 3 root 3 by this one here, what you have is 3 root 3 multiplied by root 3. First of all, this 3 you have here will be there. Remember, we said that if you multiply root a by root a, what will you have? You have a. So root 3 times root 3 is root 3. What happens is this. Root 3 times root 3 is root 9. And root 9 is 3. See that? Okay. If you divide 3 root 3 by this root 3, you have 3 remaining. Times 1. Times this 1, you have 3. You divide 3 root 3 by 3 root 3, you have 1. 1 times numerator 1, you have 1. So 3 times 3 is 9. Minus 3 plus 1. That is 11 over 3 root 3. So anytime we divide fraction, we always try to remove the irrational number from the denominator. That is what we call rationalizing the denominator. When we get to division, we will explain it better. Okay, so the purpose is to ensure that the irrational term root 3 leaves the denominator. To do that, you multiply both the numerator and denominator by the rational number in the denominator. In case of 1, if it's just one of them, okay, conjugate is used in complex or composite case. Don't bother yourself about conjugate. When we get there, we'll explain them. So to convert this number from irrational number, you multiply 11 by root 3 now. Root 3 is the rational number in the denominator. Then you also multiply the denominator by the same root 3 now. Get that? So 11 times root 3 is 11 root 3. Now root 3 times root 3 is root 9. Root 9 is 3. 3 times this 3 you have here becomes 9. So you have successfully removed the irrational number from the denominator, and that process is called rationalizing the denominator. More details in subsequent lesson. We are still dealing with addition and subtraction operations of surds. Okay, example 11. You have 3 root 28 plus 4 root 112 minus 5 root 63. Looking at these numbers, you try to get the perfect square in them. Factor of 28, that is the perfect square, you get it. 112, you get it. 63, you get it. When you do that, you are going to have 4 times 7, 16 times 7, and 9 times 7. Square root of 4 is 2. Take it outside. 2 times root 7. The next one, you have 4 root 7. Square root of 16 is 4. Square root of 9 is 3 times root 7. You multiply the coefficient, so you have 6 root 7 plus 16 root 7 minus 15 root 7. So 6 root 7 plus 16 root 7, you have 22 root 7 minus 15 root 7 is 7 root 7. 7 root 7. Okay? Example 12. 2 root 2 plus 25 whole number 3 over root 2 minus 25 whole number 4 over root 2. If you look at the last two terms, 25 is common, so we factor it out first. Factor it out. If you, this root 8 is in single form because there's a factor inside that is a perfect square. So if you express root 8 in basic form, you have 2 root 2. I'm saying this because of lesson 1. Okay, so let's simplify the bracket. Before then, you can divide 4 by 2 and you have this remaining. So you have the same denominator. What you do, you subtract the numerator. Of course, the LCM is root 3 and you have 3 minus 2 over root 2. That is 1 over root 2. So if we open this bracket and write this as a balanced fraction, you have 2 root 2 over 1 plus 25 over root 2. So the LCM is root 2. You divide root 2 by 1, you have root 2. Root 2 multiplied by 2 root 2. So this 2 is what you have here. Then root 2 times root 2 is root 4, and root 4 is 2. Divide root 2 by root 2, you have 1 times 25, you have 20. So when you add, you're going to have a 4 there. 4 plus 25, that is 29 over root 2. For us to remove the root 2 from here, you multiply both numerator and denominator by root 2 in this form. So you have 29 times root 2 is 29 root 2 over root 2 times root 2 is root 4, and root 4 is 2. So the simplest form of the answer is 29 root 2 over 2. Are you following? Okay. Example 13. Example 13, you have 2 root 18 plus 2 root 54 minus root 108. Okay, if we get at the perfect square from each of the number, you have 9 times 2, 9 times 6, 36 times 3. So root 9 is 3 times root 3. Root 9 is 3 times root 2. Root 9 is 3 times root 6. 36 is 6 times root 3. If you multiply the constant, you have 6 root 2 plus 6 root 6 minus 6 root 3. You see that after simplifying, you have different solve, unlike solve. That means you cannot add. You can neither add nor subtract. So you leave your answer in this way. Some of you think that your answer is not correct. You cancel it and write your friend's own that is wrong. Know that what you have done is correct. You have simplified. In your final state, you have different sort, and which cannot be added nor subtracted. So leave your answer at 6 root 2 plus 6 root 6 minus 6 root 3. Are you following? Okay. Example 14. So this is like solving equation. You solve for k root 28 plus root 63 minus root 3 minus root 7 equal to 0. So we have two approaches. First, let's still express them. We have to express the number for them to be in their simplest form. We are still hoping to get similar sort. So for 28, you have 4 times 7. For 63, you have 9 times 7. Root 7 is already in simplest form. For the first place, root 4 is 2. 2 times k, you have 2k root 7. The other one, you have 3 root 7 minus 7 root 7 equal to 0. You can add these two together, but you cannot add to k. So 2k root 7 will stand alone. So if you add 3 root 7 minus root 7, you have 2 root 7. If you collect like terms, so you have 2k root 7. You transfer this term without k to the right, it becomes negative. So to get k now, divide both sides by 2 root 7. So k is equal to the right hand side minus 2 root 7 divided by the coefficient of k, that is 2 root 7. Root 7 cancel root 7, divide 2 by 2, you have minus 1. Or from this step you have here, this is step you have in this place. So we are saying that root 7 is common. If you factor it outside, from the first term you have 2k remaining, from the second term you have 3, from the third term you have minus 1. So if you divide through by root 7, you divide both sides by root 7, you have 2k plus 3 minus 1 equal to 0. Because if you divide this side by root 7, this is what is left. Divide 0 by root 7, you also have 0. So 3 plus minus 1 is plus 2. So collect like 10. So you have 2k equal to 0 minus 2. That is 2k equal to minus 2. Divide both sides by 2. So k is equal to minus 2 divided by 2, and that is minus 1. That is minus 1. Okay? Example 15. Example 15. Given that square root of 128 root 18 minus root k equal to 7 root 2, find k. Find k. Okay? So you write out the expression. First, you try to express the numbers in their simplest form, hoping to get similar sort from 128, 18, and already 2 is the simplest. So we are hoping of getting root 2 from 128 and 18. When you look at it carefully, to get 2, you can express 128 as 64 times 2, 18 as 9 times 2. Square root of 64 is 8 root 2. For 9, 3 root 2 minus k equal to 7 root 2. So we collect like terms. All the terms that has root 2 on one side, while k on the other side. So you transfer plus 7 root 2 in, it becomes minus 7 root 2. If you transfer minus 7 minus root k outside, it becomes plus root k. So if you add and subtract the left hand side, 8 root 2 plus 3 root 2, that is 11 root 2 minus 7 root 2, you have 4 root 2 equal to root k. To remove the square root sign from k, you have to square both sides. It is only square that can remove square root, and it's only square root that can counter square. So you take squares of both sides in this form. So the first side, the square affects 4. 4 square means 4 times 4, 16. Root 2 square means root 2 times root 2, that is root 4, and root 4 is 2. So you have 16 times 2. Root k square means root k times root k, that is root k square equal to k. Or better still, the square root sign cancels square, only k is remaining. So therefore, k is equal to 32. So this is how we carry out addition and subtraction of surd and even sub equations involving surdic numbers. I hope you got all of that. All right. End of lesson 2. Thanks for watching and learning with PetakusEducation community. Don't forget, watch out for more from the voice of Petakus. The voice you are hearing is the voice of Petakus. For questions and inquiries, use the comment section. For the complete package of this topic, lesson 1 to 16, lesson 1 to 6, for offline usage, contact the voice of Petakus via this WhatsApp number or through the email address. Lastly, if you are not safe, your life will be in crisis. To avoid that, you give your life to the one that can save you, that is the Lord Jesus Christ, and confess him as your Lord and Savior daily. If you are saved already, I tell you big congratulations. Live righteously and be prepared, because on the last day some will be taken and some will be led. Take good care of yourself. Stay out of trouble. Stay well. Study your books. Do the needful at all times. Flee every appearance of evil. Don't defraud others. Use your hands and your brain to work genuinely, and the Lord will bless you. And goodbye for now.